Good afternoon, everyone. I'm Meghna Tail, Head of Marketing for the Energy Environment Division at HORIBA, India. And I'm delighted to welcome you all to the launch of a brand new webinar series called Eco Edge. At HORIBA, we believe that innovation and ecology go hand in hand. With our Eco Edge, our goal is to explore cutting-edge solutions that drive both industrial progress and environmental responsibility. Clean, simple, and effective. Today's session is centered around a very relevant and evolving topic. Smarter water management, Industry 4.0, and advanced TOC solutions for industrial efficiency. As industry scale and digital transformation accelerates, efficient water management is no longer just a sustainability goal. It's a critical operational need. And through this session, we aim to show how advanced TOC technologies are playing a key role in that journey. To take us through these insights, I'm pleased to introduce our speaker, Mr. John C. Matthew, Research and Application Engineer at HORIBA Tocadero, Germany. With deep expertise in TOC technology and its real-world application, John C. brings a global perspective and practical knowledge that I'm sure will add immense value to today's discussion. Thank you once again for joining us, and I now hand it over to Mr. John C. Matthew to begin the session.
Yeah. My visible and audible, right, Meghna?
Yes, it's audible.
Yeah, perfect. So, hello everyone, and a very warm welcome to all of you. I'm really happy to be here with you today. It's a special day as well. It's a World Environment Day. So this session even more meaningful because it's a World Environment Day. My name is John Matthew. I'm truly honored to host this webinar on behalf of HORIBA. Thank you so much for joining us. Today we are going to talk about a very important topic. It's called smarter water management, Industry 4.0 and advanced TOC solution for industrial efficiency. As we all know, water is very valuable. With the help of smart technologies, industries can save water and use it more wisely, of course. In this session, we will discuss something called a TOC, which means total organic carbon. We will see how modern TOC solutions and Industry 4.0 ideas can help industries manage water better and this work more efficiently, how it's worked more efficiently. A big thank you to HORIBA India for organizing this session and for all the support. In between, if you have any question, please feel to put them in the chat box. So I will try to answer them at the end. Thank you once again for being here today. So let me introduce myself. My name is John Matthew, and I work in the research and development team at HORIBA Tocadero, Berlin, Germany. I have been with the company for the past 5 years, and I have a total of 14 years of experience in the field of water and environmental instrumentation. I did my bachelor's in engineering in instrumentation and control system, and later completed my master's in scientific instrumentation. Over these years, I have worked in the research, product development, and application engineering. My main focus has always been to create better solutions for measuring and monitoring, especially in the area related to the water and the environment. In between, I would like to introduce HORIBA also. Probably you all heard about the name HORIBA before. HORIBA is a global company and its headquarters in Kyoto, Japan. It was started in October 1945, and today it was led by Mr. Atsushi HORIBA. Right now, HORIBA has around more than 10,000 employees and has presence in more than 50 locations across the globe. And HORIBA also have different sessions, and we are from the water and environmental sector. And now let me give a short introduction to HORIBA Tocadero. HORIBA Tocadero is an important part of the HORIBA group. It is based in Berlin, Germany, and works as the HORIBA's Global Center for Water Excellence in Research and Development. Tocadero was started in January 2019, and it mainly focuses on process analytics and environmental monitoring, especially in the area of next generation water analytics. Our main goal is to develop an advanced technologies that help both industries and communities manage water in smarter, of course, safer and more efficient way. That's our main focus. Here, what we will cover today in today's session. First, we will understood what Industry 4.0 means, and also learn how basic terms related to organic carbon. Then we will talk about why it is important to measure TOC, that is total organic carbon, when we check water quality. What's the importance of total organic carbon? Then we will see how, where TOC is measured in different water systems and industries. After that, I will give a short overview of common methods used to measure TOC in the current market. Then we will look into HORIBA Tocadero reagent-free TOC solutions called Tocadero Evo, which uses the UV differential conductivity method for measuring TOC. Next, we will talk about Tocadero 1, which uses 1200 degrees Celsius high temperature method to measure TOC without catalyst. It's a premium product from Tocadero. And we will also show how TOC measurement system connect with Industry 4.0. So today we are doing a webinar with two topics. First one is Industry 4.0 and TOC, how it's connected. So that's one topic I want to emphasize today. And finally, we will see how Tocadero 1 is designed to meet the needs of modern smart industries. At the end, we will have a Q&A section, so you can ask questions, of course. So first, understanding what is Industry 4.0 and organic carbon terminology. Let me explain what Industry 4.0 means in simple words. It is a fourth major change in factories or industries work. Now machines, devices, and computers are connected to the internet. They can communicate with each other and work together more smoothly. This includes smart machines or smart instruments, which we will call cyber physical system, and internet connected devices, as known as the Internet of Things or IoT, or industrial Internet of Things, IIoT. It also involves using data and smarter software to make better and faster decisions. Because of all this, factories can now produce things faster, smarter, and with more flexibility. So Industry 4.0 begins in Germany. Machines, data, and internet to make factories even better. Let's look at the main goals of Industry 4.0. First, it helps to make production more efficient. That means doing more work in less time with fewer mistakes. First goal. And the second goal is to allow industries to quickly change or adapt based on what customers need. So if the customer demand changes, the factories can adjust fast. The third one is to help companies to come with new ideas or stay ahead of the competitors in the market. So these are the main goals for the Industry 4.0. So let me introduce 4 stages of industrial development, also called 4 industrial revolutions. Industry 1.0, this was the first industrial revolution. It started when people began using steam and water-powered machines to help with work. This was a big change from using hand tools to using machines for making things. Then Industry 2.0 comes. In the second revolution, Industry 2.0 is the second revolution. This brought a mass production in factories, started using electricity, and assembly lines were introduced. This helps in making large number of products quickly at lower cost. Then comes the Industry 3.0. Probably this is the current one or the one which we are using for the last decade. This third revolution came with the computers and automation. Machines could now be controlled by computers. This made work faster, more accurate, and reduced to need people to do some task again and again. And then is the final or the current one or the future one, it's Industry 4.0. Now we are in the fourth revolution. This is all about a smart technology and internet connected machines or instruments. That means machines or sensors and computers are now linked through the internet. They can share data, they can make decisions and help factories work smarter and even more efficiently. We also use tools like Internet of Things or Industrial Internet of Things or cyber physical systems or data analytics. So these are the introduction to Industry 4.0. It started from 1.0, 2.0, 3.0, and then we are on the stage of 4.0.
Hello, Jones. Sorry to interrupt you. Your voice is echoing. Few person has raised the questions. I think your voice is not coming from your laptop. I think it's coming from some other cameras.
Okay. It's not, audibility issues? I mean, it's a
Yeah, it's echoing. It's echoing.
Just give 1 second. Give me one. I will rejoin again, please. Sorry for the trouble. Sumit, can you test it now? Is it fine now?
Yeah, now it's fine.
Okay.
It's perfectly.
Sorry for the interruption. Okay. Let me explain this. So we was with the Industry 4.0 terms, and we are coming back to the TOC. So before going to TOC, I will introduce some more terms with a simple example. So first, I would like to introduce total carbon. So total carbon means all the carbon in the water. So just imagine if you collect a water that's have a total carbon. So carbon, this is the carbon also has some different forms. I mean, the first one is total inorganic carbon, TIC. So TIC is the carbon that comes from non-living sources. For example, carbon from carbon dioxide gas in the atmosphere, or minerals like calcium carbonate in the water, or natural rocks or air mixed in the carbon. So this is total inorganic carbon. So total carbon is the carbon that comes from living things or their remains. For example, carbon from leaves or plants or animals, or even pollutions like oils and chemicals. If you see water with leaves or waste in it, the carbon is from the total organic carbon. So total carbon is the combination of total inorganic carbon and total organic carbon. Of course, there is some more terms. It's called POC or POC, volatile organic carbon, organic chemical that can easily turn into gases and evaporate. That's a volatile organic carbon. So TOC is the carbon coming from living things or their remains, and inorganic carbon is from the natural carbon dioxide gas or rocks. And the total carbon is the TOC plus TIC. So this is the basic of total organic carbon. So in simple words, TC is the total amount of carbon. TIC is the carbon from natural or non-living parts. TOC is the carbon from living or once living things. VOCs are organic chemicals that can easily evaporate and pollute water and air. So these are the main terms. But we focus on TOC a lot because it helps us to understand how much pollution or organic matter is in the water. So that's why TOC is important. So the question is, why is measuring total organic carbon or TOC is important in water quality analysis? Why should we measure total organic carbon or TOC in water? Let me explain why it is important to measure total organic carbon or TOC in water. First, TOC gives a reliable measure of all the organic pollution in water. This include things like decayed plants or oils or fat or sugars and some organic materials. Then measuring TOC help us to make sure water is clean and safe. This is very important for drinking water or industrial use and protecting natural rivers or lakes. So organic matter is a kind of pollution. That's why TOC is important. So TOC measurement is accepted worldwide because many industries or governments or all the nations or the regulatory bodies use TOC test based on TOC test as the base of water quality. And this is also based on some international standards like ISO standard or DIN standard. So it's a standardized things for measuring the purity of water. Then TOC is also measures the total organic content in water. It does not check for each individual chemicals or but gives an overall picture of organic pollution. This make it very useful for monitoring total contamination. So basically, the TOC is not specifically measuring anything. It's measuring total organic content or total contamination. That's the reason TOC is also important. Then the one big advantage is that compared to other analysis or method, modern TOC analyzers or instruments are fast and safe and easy to use. And most of the instruments can work or measure without using harmful chemicals or catalyst or complicated steps. So it's an easy process, and in a short term, we can measure TOC. So that's why TOC is also a thing which we can easily measure. So that's also one of the main advantage of TOC measurement. And measuring TOC helps, of course, it protects health and the environment because water is the main resources what we have. It also helps industries follows laws and rules. So compliance, some industries need to compliance with the local regulations. And water quality by detecting pollution early and supporting good water treatment. So that's a basic requirement. So this is also TOC is important. So next question is, where should I measure total organic carbon? The answer is simple. Whenever water purity or the environment matters, we should measure TOC. Probably if water is used directly in making products, edible products or any product, then TOC measurement is needed, of course. If you are using a steam water, reusing in boilers or turbines, TOC must be checked to avoid problems in the industrial hardware. And if you need to stop rust or dirt on the heating system, TOC help us to monitor this. Because TOC is a pollution measurement criteria. So if machines are cleaned often, like in pharmaceutical or food industries, so TOC testing is so important, because here we are using ultra pure or pure water. We don't need any impurity there. And if treated water is tested before letting into environment, TOC should be measured, and it need to be keep it safe, the environment. And if very low organic carbon levels are needed for special things like making electronics or computer chips, or TOC water or semiconductors, TOC measurement is so essential, because here is ultra pure water is running. And if water is running from factories or airports, it's a de-icing. Probably in India, it's not that much important, but that's also TOC helps to control pollution. In short, wherever water quality matters, measuring TOC should be the part of the process. So these are the basic applications. It's not limited, but the major applications. So next question, how can total organic carbon TOC be measured? So let me explain how different TOC measurement method work. The first method is 254 nm nanometer optical absorption TOC. In this method, UV light at 254 nanometers passes through the water sample. The organic compounds absorb the UV light. The amount of light absorbed shows how much organic carbon in the water. So the amount of light absorption is proportional to this organic carbon or TOC. This is the optical absorption method. This is a kind of a less precise method, and this only helps to understand the trend, not the exact quantification of the TOC. It's only giving a trend of the measurement. The next method is UV differential conductivity. This method measures water conductivity before. If you have water, we will measure conductivity before, and then we will pass through the UV light. And the UV light basically breaks down the organic material. So once the organic material is break down, the conductivity will increase. And then we will measure outlet conductivity, or after the UV light. Then we have a differential conductivity. That means outlet conductivity minus inlet conductivity, that is change in conductivity. And this conductivity tells, or it's proportional to the amount of organic carbon oxidized. This is the UV differential conductivity method. And this is simple method, and it's a reagent-free method. And the basic application lies in ultra pure or pure water application. Then the next method is UV persulfate oxidation method. Here the water sample is mixed with a persulfate. It's a chemical, persulfate chemical, and then exposed to UV light. So previously it's just an UV light exposure, but here it's exposing. Sorry. It's exposing to persulfate chemical and then exposing to UV light. This breaks down the organics and produces carbon dioxide. This CO2 is measured with an infrared detector, and this is a proportional to TOC amount. So this is the UV persulfate oxidation. So we need a persulfate chemical for this, and we cannot use it for very high range, maximum 0 to 50 or 0 to 20. That's the range for measurement, ppm. That's the range for measurement of TOC. Then we have two-stage advanced oxidation. Here, ozone gas is added to partially oxidize the organic. So ozone is using to oxidize the water, and then sample is heated to about around 700 degrees Celsius with the catalyst. This fully break down the organics and producing CO2. So here ozone and a kind of temperature of 700 degrees Celsius is using to oxidize it. Basically, for measuring TOC means we need to oxidize the sample or water, then only we can measure. So oxidization is the criteria for measurement of TOC, and this here we are using ozone as an oxidizing agent, and then we will give to at 680 degree or 700 degrees Celsius, and then it will break down to CO2, and which is using an infrared sensor or NDR sensor, non-infrared NDR sensor, and then we are measuring CO2 gas. Then the other next method is catalyst combustion method. So water sample is put into a furnace, are also around 700 degrees Celsius, and we use a catalyst, example platinum or some other catalyst, and the organic carbon burns into CO2 gas in presence of catalyst. So this is the other method to measure TOC. So we are using a catalyst called a platinum catalyst or other catalyst to measure TOC, and then we are using with an NDR detector to measure TOC. The final method is 1200 degree high temperature non-catalyst combustion method. So here we are not using any catalyst. So we are using energy to burn or to make oxidation. So the sample is burned at very high heat. It's around 1200 degrees Celsius without catalyst. So this will make sure that the sample is fully oxidized to organics to CO2. This CO2 is then measured in using an NDR detector and finding a TOC. These are the main methods basically, and so next question, how is TOC measured using UV differential conductivity method without reagents or catalyst? So basically we will show you without how TOC can measured without reagent or catalyst or some oxidizing agent. The first method is UV differential conductivity method, as I mentioned before. This is specifically for low range measurement for ultra pure and pure water. So in this method, we does not use any chemicals or catalysts. So this method measures TOC by combining UV light and conductivity detection. It is simple and works without adding any extra reagent. The water sample is directly exposed to a UV lamp. Here you can see a UV lamp, and this NS, and it's a conductivity, conductivity. So this is the UV reactor or UV lamp, and we have an inlet conductivity sensor. This is the inlet conductivity sensor, and this is the outlet conductivity sensor. So so the water sample is directly exposed to UV lamp, and the UV lamp break down the organic compounds in the water. So that means there is no need of any chemical. And then UV lamp break down the organic carbon. This organic carbon will change to carbonate and bicarbonate ions. This will increase the conductivity of this sample. So we will measure the outlet conductivity using this outlet conductivity sensor. So we have inlet conductivity sensor, and then we have a UV lamp here. So the water will flow continuously to the UV lamp, and UV lamp will break down the organic components into carbonate and bicarbonate ions, and this will increase the conductivity of the sample, and this will go to the outlet conductivity sensor, which is placed on the which is placed here, and then the ions will increase the water conductivity, and the more organic carbon in the water, that means higher conductivity. So by measuring how much conductivity increase after UV exposure, we can find out exact amount of TOC in water. This method is very useful for real-time and accurate monitoring for water quality. It is often used where very pure water is needed, like pharmaceutical or electronic manufacturing industries. For this method, the HORIBA Tocadero solution is Tocadero Evo. The application is pure water and ultra pure water. So here, Evo, HORIBA Tocadero Evo is measuring TOC in pure water and ultra pure water without using any reagents or catalyst. And it works perfectly for pure water and ultra pure water application. It's not needed any chemicals or catalyst for measuring TOC, and the level or the measurement level is 0 to 1000 ppb, means 0 to 1 ppm. And it can detect very small amounts with a limit of detection 0.1 ppb and accuracy plus or minus 0.05 ppb. And it works well in the very low conductivity water, less than 2 microsiemens, and it's very fast for measuring TOC. So the instrument or the sensor will give a reading in 1 second. So every 1 second you have a online real-time value with the instrument. So of course, the instrument don't have any no moving parts. So it's ideal for ultra pure pharmaceutical or the electronic manufacturing industries, and it's only use very few consumables. And the UV lamp is only one main consumable that's only need to be changed once in a year. So over a whole year operation, it's not need any consumable at all. So the next one, the method which I am going to explain is how TOC is measured using high temperature, non-catalytic combustion at 1200 degrees Celsius. So in this method, the water is burned at very high temperature, about 1200 degrees Celsius. So initially, water will be prepared in a preparation vessel, and then we will remove total inorganic carbon removal, because we are intended to measure TOC. So we need to remove TIC. So initially we will using a carrier gas or purging mechanism, we will remove the TIC from water. Then we will inject the sample to the furnace. Here we are keeping a furnace at 1200 degrees Celsius. It's called high temperature combustion technology. So the furnace is always heated at 1200 degrees Celsius. And at high temperature, because of the high temperature, the organic carbon in the sample is fully burnt and turned into carbon dioxide. So the organic components of the water sample will be completely turned into carbon dioxide without catalyst. So that's with only with the energy or chemical, and then it will go to a cooler to because the gas coming out from the the furnace is it's a high temperature gas, so it need to be cooled down, and then it's going to be a cooler, and cooler is keep at 5 degrees Celsius, and then we will take into the NDR detector, and non-dispersive infrared NDR detector will give the TOC value. So this is the measurement mechanism at high temperature non-catalytic combustion method, and CO2 is produced without any catalyst or chemicals, and then CO2 is measured using a special sensor called NDR sensor. And this method gives very accurate result, and this also ensures complete oxidation. Because other methods we need catalyst or some other chemicals to oxidize it, but we will make sure that at 1200 degrees Celsius, all the organic components in the water will be oxidized to CO2, and this ensures complete oxidation, and all the organic carbon in the sample is converted to CO2, and this will be measured using NDR detector. This is the basic principle of the high temperature combustion, non-catalyst combustion method. And HORIBA Tocadero HORIBA Tocadero solution is Tocadero 1, and here it's a mistake. It's not Evo, it's a 1. And the application lies in pure water, process water, wastewater, because the measurement range for this instrument is 0 to 100,000 ppm. So it's not limited for any low concentration, or don't have any disadvantage with any other process or chemicals or any forms of water. So it's a completely, it can measure a TOC in all type of water, from a very clean pure water to wastewater, covering a range of 0 ppm to more than 100,000 ppm. And this analyzer is a next generation TOC analyzer. We call this a next generation TOC analyzer with advanced features. So it supports predictive maintenance using Industry 4.0 and industry IoT technology. So this means that we can plan the service before any problem happen. And it's only need one maintenance per year. It's also saving time and effort for the user. And the high temperature, 1200 degree high temperature combustion is very accurate for TOC measurement. That's one additional advantage without catalyst. And one more thing is that analyzer has super fast cycle time. So it's giving a quick result. It means that the analyzer can give a TOC measurement in less than 3 minutes, which is the fastest analyzer for TOC measurement. And then TC, total carbon, it can be measured in less than 1 minute. And this is this analyzer is designed for user friendly, and it's a completely made in Germany analyzer, and it's made easy for operation, and it support all the main communication protocols like OPC UA or Profinet or field bus, Modbus, and the normal or the traditional analog for 0 to 20 or 4 to 20 milliampere analog, or it's have a digital input outputs, and including a Bluetooth and Ethernet and GSM modem or WLAN. So it's a completely a professional 4.0 analyzer. And the analyzer can measure not only TOC but also total carbon, means the all carbon in water. So the different TOC difference method, there is some different method for measuring TOC, like TOC difference or TOC addition. So any methods, these all are TIN standards or standards to measure TOC. So all these kind of or any kind of or type of measurement criteria can be fulfilled within the analyzer. And there is no, and it can also measure TIC, total carbon, and TOC and total nitrogen, and also can measure VOC, volatile organic carbon, or POC. So this is a completely a flexible analyzer, and wide because it's a Tocadero 1 is used for many water quality measurement without any any other kind of disadvantages. So this is the Tocadero 1 analyzer. So there is a lot of features, and most of the features are a kind of things no other analyzers in the world have this kind of additional features or things that's Industry 4.0 required. So Tocadero 1 analyzer is very flexible and easy to use, and it can the user can choose different methods and detectors for measuring TOC. And it can also handle sample pre-treatment, and also have smart features like automatic cleaning or predictive maintenance. It also adapts different water types without hardware changes or accurate result with minimum maintenance. And it's also reliable and efficient for any kind of water quality requirement. So these are the main solutions or features which comes with the Tocadero 1. So next question is that are you using Industry 4.0 TOC solution, and how Tocadero 1 is adapting to Industry 4.0 requirements? So what is next generation water analytics? That's the question. So comes to the communication. So if you want a true industry 4.0 instrument, it must have the right communication features. So this include a modern HMI, means a high resolution touch display with a, of course, like a mobile phone, with a touch display with a swipe and slide operation, and easy to understand menus. It should be a requirement like our mobile phone. That's it should be a handheld small display. And on the hardware side, it should support different kind of communication protocol. So it should support the state-of-art analog outputs, 0 to 20 milliampere or 4 to 20 milliampere output. That's the common or the old industry required. And it should show the status, or and it should include all the digital outputs. And it should have a connectivity with Ethernet with the flexible IP settings, or dynamic IP or static IP, or Wi-Fi, GSM, Bluetooth for wireless connectivity. And it should also speak modern protocols like OPC UA or Modbus or Profinet or Fieldbus. All these features ensure instrument can connect easily, share data, and support smart automation industry 4.0 environment. So that's a requirement of communication. So comes to the status monitoring, because status monitoring is one of the important things, because to know the analyzer status, or to know the health of the instrument, that's so important for the next generation water analytics. A smart 4.0 instrument should also have a status monitoring feature. It should not. It should support multiple sensor integration, because the status is communicating to the user using multiple sensors. So like additional level sensor to control sample feed. Is it sample is already there? Or multiple temperature sensors across the system to check the cooling function, or how heat the environment or internal things, and to check the cooling system, how it's efficiently operating the cooling function, and how the pressure or how the flow or how the pressure pump is working. So these are all important to monitor the hardware maintenance thing. So it should have a status cockpit that shows a clear system status, tracks trends, and gives an easy to understand error message with a visual indication. So these are the main things that's required for status monitoring. Also, it should need a predictive maintenance feature. That means that the instrument should estimate automatically the life of the key consumable part. And it should automatically predict when service is required, and it should also plan its maintenance based on the real usage. So because sometimes the analyzer is not using, and we may not need any maintenance at all. So this helps avoid unexpected breakdowns or shutdowns, and it also supports scheduled downtime with a full tracking of performance and the peak data. So this is also important for a for industry 4.0 analyzer. So comes to this servicing. This is also important. When it comes to the service and support, the instrument should also be future ready with augmented reality. So service team can use smart glasses and tools to get live support. So smart glasses or augmented reality means what the service technician in the site is seeing. So it can, the same view is visible to the support team anywhere of the world. So this is the augmented reality smart glasses, and it should access manual service node and hands-free and efficiently. So and it also should have a remote access and remote control when it's required. So it means that the instrument can be connected worldwide using a 4G or 5G, and it can be the same software or same control mechanism can be used, or the same maintenance things can be done anywhere, any part of the world, or can support from any part of the world using the remote control access. So the software can update and easily through USB or Wi-Fi or internet, and users and service can easily access and control the instrument remotely whenever needed from any part of the globe. So this is the with advanced service management, we will get a regular status and measurement reports or instant alert through email or push messages, and even the option to store data securely in the cloud. So these are the main things comes to the service industry 4.0 is looking for. Here the analyzer. So the next generation TOC instrument means it should have a state-of-art measurement technology. So it should have the state-of-art technology for measurement, along with the modern communication. So it's an added thing. The modern communication features or predictive maintenance and the remote service support. And it should also be equipped with the Industry 4.0 and industrial Internet of Things capabilities. So this is exactly what HORIBA is offering to its customers with advanced, smart, and reliable TOC solutions built for the future. This is the remote control. Here you can see the remote control things which the same software can access any part of the world. So this is the analyzer status. The instrument will tell what the exact issues and where the requirement of service, and the cockpit which is giving a predictive maintenance indication, the health status and everything. Here you can see a health symbol, and the verification of the process, that's also important. This is an example of next generation water analytics, where you can control your TOC instrument from any part of anywhere in the world. The same touchscreen operation you can do on the analyzer, you can do it remotely, just like you are standing in front of the devices. You can perform calibration or validation check and or many service activities without even visiting the site. So the instrument also monitors the health status and gives regular updates. It can predict when maintenance is needed. So you can plan in advance. This combination of advanced technology and Industry 4.0 features make it life much easier for engineers or plant management. Of course, this will save time, and of course it will save cost, and of course it will save the effort or manpower required for maintenance. So this here you can see augmented reality feature, which how the augmented reality is working. Yeah, thank you, and we are on time, and thank you so much. And probably now we can start the question answer section.
Thank you, Johnson, for the wonderful presentation. Now we are open for Q&A. So you can please write down your questions on the chat box, or either you can raise your hand.
Okay, so okay, so one question is here. So how TIC were purged out with CO2 free air? Please share your views. Okay. So basically, as I mentioned before, the water sometimes have a TIC. So we need to measure. We need to measure TOC. We just need to measure TOC. We need to remove TIC. So for this one, we need to reduce the pH of the sample. So that's the reason we will add a few drops of a few microliters of acid, a mild acid to the sample. It's called a sample preparation stage. So we will add a mild 1% HCl, hydrochloric acid, to the sample. So once we added 1% mild, it will reduce the pH of the sample. It's called a sample preparation. Once the sample is prepared, we will purge it out this TIC, because TIC it's a purgeable thing. So we will introduce a carrier gas to the sample. So the carrier gas will mix the sample. The process is called purging. So we will make a purging, depends on the TOC level from 20 seconds or 30 seconds. So depends, if higher TIC, we will purge it for 1 minute. So once purging means we are adding energy to the sample. So we are mixing up well. So the TIC will be removed automatically from the sample. Then the balanced sample only have a TOC. So and this sample is only we are going to inject to the furnace. That's how we are removing TIC with the purge air. And we will make sure that the sample only have TOC once it's injecting to the furnace.
So basically, you are changing the pH and trying to reach the TIC part and purging out.
Right. We are reducing the pH of the sample, and then we will give energy by carrier gas. We will give an energy as a carrier gas, so it will mix it up the sample very well. So so the TIC will remove our gaseous format.
But how long this process will be continued? Because we don't know how much is TIC and how much is TOC. So how we are sure that entire TIC has been purged out?
True. That's a good question. Basically, most of the TOC applications, the customer have a good knowledge about what the normal measurement range of TIC, or because in laboratory result they have enough result. So and the second criteria is that this is a kind of a programmable things on the software. So if you think that, or the users think that, or the service technicians think that the sample already have a good amount of TIC, we need to increase the purging time. So if you are not giving a good repeatability on the instrument, probably you need to increase the purging time 1 minute or 1.5 minutes, or you can increase even 2 minutes or 3 minutes. So depends on the TIC, we need to increase the time of the purging. That's how, because we need to purge it out complete TIC. So that's our aim. So accordingly, we need to program the instrument how much time we need to purge it out.
So basically, what I can understand, the best way of doing is take the sample, go to the lab, identify how much is that, then program the instrument or the time period of purging out of the TIC and proceed. Is that correct way of doing?
That's the best practices, because you don't need to do it every time. You only need to test one time, because the instrument is it's not a portable one. It's an instrument, so the sample is almost safe. The second thing is that if you are not getting a good repeatability, because if TIC is already also on the sample, you should not get a good repeatability. So if you think that you are not getting good repeatability, you need to increase the purging time. So that means that purging will remove complete TIC in the sample.
Okay. Last question from my side.
Yeah.
Can we do multi-stream?
Right. We can, because multi-stream is not, this is a batch process. So the T1 instrument is come with a 2 streams option. So 2 stream option means it's a batch process. First stream first, and then secondary. That of course it's possible.
Thank you very much. Thank you very much.
Welcome. So there is one more question is, so is it suitable for DI water for electrolysis process? Of course, the instrument is Tocadero Evo. That's because the DI water is considered as pure water or ultra pure water. So The TOC measurement usually it's less than 1 ppm. So it's EVO is capable of measuring electrolysis water, and the main application lies in the hydrogen production. That's also possible. So any other questions?
Hi, Mr. Vinayak, you can please unmute yourself and ask your question.
Hi, thank you. I have received a very good answer from Johns, so I don't have any query right now.
Okay, so thank you so much. Johnson, one question is from Mr. Anshuman. He's asking, will it be useful for semiconductor industry also?
True. Semiconductor, it's using ultra pure water. It's the water is of course the TOC measurement should be less than 20 ppb or 10 ppb. So Trocadero Evo is capable of measuring or it's useful for measuring TOC in the semiconductor.
And the second question from him is, will it can be used in green hydrogen plant?
It depends on where we need to put it and what's the application. Because Trocadero Evo and Trocadero One, both instruments, so how we managing the application is that depends on the application. We will provide our suggestion, or HORIBA India sales engineers can support you, or sales product managers can support you this one. So basically both instruments is completely capable of measuring 0 ppb to 100,000 ppb. So it totally depends on the application, so where you need to put the instrument. So my answer is straightforward. We can use it in any applications. We don't have any restrictions at all for both instruments. So both instruments are covering all the applications. So that's my the common answer for the question.
Roshan, you can please unmute yourself and ask your question. And Anshuman, you can also please unmute yourself and ask if any more questions. So I'll just read the question from Roshni. So how do you remove the amount of CO2 that generated at lower pH levels from carbonates and bicarbonates?
So can you ask? Can you say again the question?
Yeah, I'll just repeat it. Repeat the question. So how do you remove the amount of CO2 that generated at lower pH levels from carbonates and bicarbonates?
CO2 removed?
Only from bicarbonates, not from carbonates.
Okay, so I think basically I think the question is mixing with two instruments. So UV oxidation, ma'am, you are saying about which method you are specifically saying? Is it with the UV differential method, or one at the high temperature combustion method?
Combustion method.
Combustion method. Okay. So basically, during purging process, so if there is any carbonate or those kind of CO2, it's automatically removed. So because this during purging process, these gases is not going for measurement things. So this is completely removing through the purging process. That's called a sample preparation stage.
Okay. Is there any way to remove carbon dioxide from the sample then?
Of course, because the system is how multiple once you see the PID diagram of the instruments, so it's how a kind of different kind of three-way valve. So depends on the process. So during sample preparation process, sample preparation means we will take the sample to the sample preparation vessel, and then we will mix it up with a acid, 1% HCl mild acid. Then we will start purging. So it's called a preparation stage. So during preparation stage, those kind of CO2s are completely removing it. So only the organic material is keeping back to the sample. So that's called a preparation stage.
Okay.
So and then this sample, this sample is injecting to the furnace. So up to the furnace, it's a liquid form, and once it's injected to the furnace, we are injecting around 200 microliter of sample. So once it's injected to the furnace, it's going to be oxidized. So before oxidizing, we are removing those kind of CO2 which are bicarbonates or carbonates during the sample preparation process. So we will make sure that only organic sample or organic component sample is going to the oxidation.
Okay, and likewise, it removes the dissolved carbon dioxide as well, right?
Right.
Okay. You are.
It's a sample preparation. It's a sample preparation.
Okay.
That's the reason we include a sample preparation stage before injecting. We are not directly injecting it.
Okay, then thank you so much for your answer.
So, yeah.
I think thank you everyone for joining this session of EcoEdge webinar series.
Mike, one more question. Can you provide informed competitive products which companies are dealing same kind of products and how we are better than others? Anyway, I'm not going to use the names of the companies which are in the market, but basically there are different companies which are measuring TOC. And during one slides which I presented before, the technologies like catalyst combustion or advanced two-stage combustion. So these are the techniques which other companies are following. But HORIBA Tocadero is a premium kind of instruments which only 2 companies in the world is measuring TOC with a high temperature combustion technology or at 1200 degrees Celsius. And the best part of this technology is that, or the UV differential, there is no requirement of catalyst or chemicals. So basically all other companies, they are measuring TOC using catalyst. So catalyst is always an expensive, it's a consumable for each measurement. So, and we are providing an instrument without catalyst. And additionally, this is the only analyzer with have 4.0 or industry 4.0 or next generation water analytics features, like including the predictive method. So we are working more for the next generation TOC measurement and adding for state of art 1200 degrees Celsius non-catalyst combustion. So both instruments at only 2, as I mentioned before, only 2 instruments in the world are producing at this technology, and both instruments are coming from Berlin. Yeah, Meghna. And before you are, of course, I just want to say, I hope this session was helpful, and of course, I believe that you have some valuable insight. So, on behalf of HORIBA and HORIBA Tokadero and HORIBA India, I would like to thank you again for being part of this session. If you have any further questions or of course, you can contact HORIBA India, or you can also directly contact HORIBA Tokadero. And thank you so much. And we are looking forward for your applications. And if so, getting some insight about our product, we are so happy if you can also follow our HORIBA Tokadero LinkedIn page. We are updating continuously our products, portfolio, and applications notes. And wishing you all the best. And once again, thank you for being here, and have a great day ahead. Thank you.
Thank you, Johnson, for the closing remarks. So just one last thing. So I've dropped an email ID. Please do email us for any sort of inquiry or any questions. Thank you so much for joining. So we'll see you for the next webinar session for EcoEdge.
Thank you.
Thank you. Thank you so much.
Thank you. Bye.
Good day. Bye-bye.
Bye.
Thanks, Jose.
Thank you, Johnson.
End कर दिया